Hey guys, this is Math 116, Section 6.4, the present value of annuities. And present value is a really interesting concept in finance and in our lives, but it's a little tricky to be thinking about because some people aren't used to thinking about the present value of money. So the present value in general is how much money do you need today to put down in order to get the, I'll call it regular payments that you would want with an annuity. So remember in section 6.3, you were putting money away at either at the beginning of the month if it was an annuity due, or at the end of the month, and then they said, how much money do you have after 5 years? Well, now they're saying, how much money do you need now in order to get the regular payments? So the idea is this sort of the old proverb, a bird in the hand is worth two in the bush. The idea is what you need today is different from what you're going to get in the future, assuming you get two birds in a bush in the future, which is really unlikely. I'm just going to say that right now. So the first thing I'm going to do to present this section is I'm going to read you the problem and then explain what it means. So don't panic. Here's question number 5. Find the present value of an annuity of $6,000 paid at the end of each 6-month period for 8 years if the interest rate is 8% compounded semi-annually. Ah, words! I have many students, especially high school students, that when they see a problem with too many words, it's hard. So, words, they're hard. So the present value of an annuity. I'm going to go to my paint picture. This is what it's saying. So they're saying, we have some chunk of money that you're going to put in, right? Here's your chunk of money. It's in a big bank. I'll put a roof over the top of it. And you're going to get, was it $6,000? It was $6,000 at the end of every 6-month period. So you're going to wait 6 months, and then you get $6,000. And then you're going to wait another 6 months, and then you're going to get another $6,000, right? And at the end of 8 years, right? This is going to happen for 8 years. And then you're going to be out of money. And the interest rate during this time is 8% compounded semi-annually. So the question, compounded semi-annually. Sorry, I'm writing so small. So the question is, how much money do you need here? This little house is the house of present value. It sounds like a restaurant. A very excellent financial restaurant. The house of, stop it, of present value. So, in order to answer these questions, you need the formula. So present value. So if you're reading this problem on a test, two things jump out at you. Present value, okay, that means a present value formula, of an annuity paid at the end of each 6-month period. This at the end tells you it's an, let's see if I can spell, ordinary annuity. So end means ordinary. It's over. Here's your formula. Present value of an ordinary annuity. What does ordinary mean? It means paid at the end. There's no end there, except it's the end. Here's your formula. This is the present value. That's the house of present value, is R, the number of payments made at the end of each period, times this formula, 1 minus 1 plus I to the negative n divided by I. N is the number of periods, and I is the interest rate. And you could probably get this formula yourself by taking the future value and reversing it, but you probably, for most of you, are just going to want to write this down. So I'm not deriving this formula for you. I'm just showing you right now how to use it. So here's the formula. Let's go use it. Let's use it for this problem. So in this situation, our regular payments are $6,000. So you're getting $6,000 back. Yay, you. Every 6 months you get $6,000. Thanks, Grandma. And N, which is the number of periods. So basically, how many checks are you getting? Imagine your grandma's putting this money in. This is what you're getting. That's a nice way to think about it, isn't it? So you have 8 years, and she's giving it to you every 6 months, so 2 times a year. So that's a total of 16 periods. So imagine you're getting paid 16 times because it's semi-annually. Semi-annually means twice a year. And then, so that's N. And the interest rate is going to be 8%, but it's per period, so we divide by 2. So it's essentially 0.04, because it's, again, semi-annually, 2 times per year. It's compounded. So your interest rate is 0.04%, and you can think of this as per period. So now we're just going to use the formula. Here it is. So the formula, the present value, this is how much Grandma's putting away for you. Here, I'm going to write it again. R, the amount of money you get for each check, minus 1 plus I to the negative n, all divided by I. And if you're writing this on your note card, you're going to want to write present value, or you could say PV, of ordinary annuity, and you might write parentheses and paid at the end. In this case, we have $6,000 times 1 plus 1, minus, that's a giant minus sign, 1 minus 1 plus 0.04 raised to the negative 16. Where does 16 come from? 16 periods. Negative 16, all divided by I, which is 0.04. Again, that's minus, minus. This is 6,000 times, this whole thing here, when you plug it into your calculator, is 11.65229, approximately. So your final answer is equal to I better write it down here. It's a big number. I didn't have room. $69,913.77. So that's your annuity due. So Grandma, your grandma, thanks Grandma, is putting $69,913.77 in here in some fund, and then it's paying out in this rate. So let's look at another problem. Question number 10. This is a little bit the same problem, going a little bit different way of looking at it. $88,000 is invested in an annuity that earns 5.8% compounded quarterly. What payments will it provide at the end of each quarter? Notice the quarterly compounding is consistent for the next 5.5 years. Okay, so again, here's our picture. So now, in our house of money, where they keep all the money, we have $88,000. And we're going to compound quarterly, so every 3 months, right, because it's quarterly, every 3 months you're going to get a little payment, right? You get a little paycheck every 3 months. And it's at and at the end this is going to keep going for 5.5 years. You're going to get these payments, right? 5.5 years. You're done. And you're making 5.8%. So this is similar to the previous situation, but it's a little bit different because now we know how much money we're starting with, but we don't know how much our checks are going to be. So in this situation, you know that Grandma's putting in $88,000, and you're wondering, how much am I going to get every 3 months? So here's the formula. It's the same formula, present value of an ordinary annuity. How do I know it's an ordinary annuity? Look, at the end. At the end. So I'm trying to highlight at the end. It's not like we're not trying to make it super complicated. If it says at the end, it's an ordinary annuity. So we're going to use this formula, but now we're going to solve for R, because R is the amount of the check. That's the amount of the payment. So here's the formula. Let's do it. I'm going to talk quietly. Maybe not that quietly. So in this case, here's the formula. A to the n equals R, that's the payment, times 1 minus 1 plus I to the negative n, all divided by I. So much. In this case, A to the n is $88,000, because that's the present value, right? R is a question mark. We do not know. This would be the payment. We don't know the payment. The interest rate is equal to 0.058, because 5.8% is 0.058, don't write 5.8 or something, divided by 4, because it's quarterly, which is equal to 0.0145, and n, which is the number of periods, it's 4 periods, so 4 quarters per year, times how many years? 5.5 years. So 5.5 equals 22 periods. These take up a little paper, but not as much paper as the Gauss-Jordan method. So here's how it works. We have A to the n, $88,000. That was the A to the n part. Is equal to R. We don't know what R is. Times 1 minus 1 plus I, which is 0.015. 0.0145, that's a point, raised to the negative 22, all divided by I, which is 0.0145. So I'm going to try to speed this up so you guys don't have to watch this video forever. So this is 88,000 times R, this whole piece, plug it into the calculator, I dare you, equals 18.7212. So R is equal to $88,000, grandma's big chunk of change, divided by 18.7212, that's a 7, is equal to what? 4700.55. So what does this mean? This means that if you, or better yet someone else, put in $88,000 at the every 3 months, so every quarter, you're going to get a little check for $4,700 and some change. So yay, that's nice. Okay, so one last question. If we have ordinary annuities, yes, you have annuities due. This is question 21. What amount needs to be set aside now to generate payments of $50,000 at the beginning of each year for the next 12 years if the money is worth 5.92% compounded annually? Okay, beginning of each year. This jumps out at you. It leaps across the page. Bold. Come on, bold. Anyway, beginning tells you that this is an annuity due equals beginning. It's due at the beginning of the month. So for the next 12 years, and this is the amount for the regular payments. So here's the new formula. Present value, because that's the money you need at the beginning of all of this, of an annuity due is right here. It's the same formula. The only difference is we have this piece here that represents the additional month because you're paying at the beginning of the month, so you have one extra payment. So again, R are the payments, N is the number of periods, and I is the interest rate. If I can make all of that bolded. Close enough. So, I'm going to write this problem out. So in this case, here's our house of money. And we are saying how much money, here's the house of money, how much money do we have to put in here so that at the beginning of each month, we're going to get, or not each month, every 6 months. Sorry, I'm just checking. Nope, beginning of each year. The beginning of each year, you get $50,000. So imagine this is a retirement fund, and you want to get $50,000, and this is going to go on for 12 years. So I had a friend who was a Microsoft guy, and he was in Microsoft early, and he was able to retire off of his Microsoft stuff and go, and he got a little compound in Mexico. So suppose my friend Brian, you know Brian? Everybody knows Brian in Seattle. Anyway, suppose he wanted to put money aside, so at the beginning of each year, he's going to just get $50,000 to fund his little time in Mexico. How much money does he have to put in here? This is the annuity due formula because it's at the beginning of each year. So in this case, R, that's the payments. So every year at the beginning, he's getting $50,000. I is equal to the interest rate is 5.9%, so 0.059. How many times a year is it compounded? 1, because he's getting the payment every year. So in this case, it's just 0.059. And N, which is the number of periods, in this case, he's getting paid every year, so it's just 12. So you could think 12 times 1 time a year equals 12. Okay? So it's beginning of each year. In this case, they were compounding annually. Let's plug it into the formula. So the A, and the formula says N, so annuity due, so it's at the beginning of the month, equals $50,000. That is, sorry, Malwarebytes, don't care. $50,000 times, that's R, 1 minus 1 plus 0.0592, all raised to the negative 12 years you're going to spend in Mexico, divided by the interest rate, 0.0592, times 1 plus 0.0592. Didn't have enough paper. This equals $50,000. I'm going to give you a little intermediate step. This whole piece, when you plug it in, gets about 8.4207 times, this is 1.0592, which is equal to 445 962.22. And the way we note this is AN due. But again, what this means is if you are my friend and you want to take your Microsoft money, you're going to need $445,962 you're going to put aside into this annuity, and then you're going to get your big check at the beginning of every year, $50,000, to live in Mexico and have an excellent time for 12 years. And it's paying this interest rate. So that is how you work those problems. You're thinking about how much money do you need to put down at the beginning in order to get these regular payments. So look over those homework, but these problems should really help you with the practice test and the quiz.